Good day, ladies and gentlemen. Once again, is another opportunity for me to give you my last input on the topic of compound interest, a very comprehensive example, which is example 3.6, that covers most, if not all, the dimensions of compound interest. So in this example that I will be recording, I will answer all the questions, which is number A, B, C, and D at the same time. So it will be kind of a comprehensive question. But I like such type of questions because it will make me to do a relationship between some of the components of the questions that I will be responding to. Now, compound interest, we are given information at this time in a table where we have S indicating the future value, which is sum accumulated. So we do have our future value already. Remember, when the amount of the future value is provided and we are using our financial calculator, we press plus or minus all the time when it comes to the future value. Then present value, which is A, or present value, is what is missing. So that means when we press in our calculator, we need to say compute or comp present value, because that is where the question mark is. We are looking for the amount that was initially invested. The interest per annum, it is 8.55% per annum, and the number of years this amount was invested, it is 5 3/4. And I want to highlight this 5 3/4, and is important in terms of how to convert the 3/4. Then the frequency, which is our M that I spoke about several times, is quarterly. That means every quarter we earn interest, and this interest gets to be added to the present value, or the amount that we initially invested. So now remember once again that a quarter is made of 3 months. So now whenever we speak of a quarter, in the case of a year, a quarter is made of 3 months, because there are 12 months in a year and there are 4 quarters in a year. So now if you say 12 divided by 4, you will discover that a quarter is made of 3 months. And it is very important to master the fact that a quarter is made out of 3 months, because I will be explaining that in details as we proceed in this question, and also when we go further to annuities. Now, we have quarterly compounds, which is 3 months, and what are we looking for? We are looking for the present value, and all other factors are given to us. Remember, I did mention to you that in the formula that we spoke about previously, let me just go back to the formula just to recap a little bit, in case maybe you don't remember, but I will not do this again. If you remember that in our formula we said I must always be divided by M, and we said that M is the number of times the interest is compounded in a year, of which now in this case our interest is compounded quarterly. So now that means when it comes to our I, and when we press in our calculator, we need to divide by the number of compounds in a year, of which there are 4 quarters in a year in this case. So now when we punch our I, or press our I in our calculator, we need to make sure that we divide by 4, which is the number of compounds in a period, or the number of compounding period in a year, which in this case it is quarterly, meaning it is 4 times in a year. Now let us record the numbers that we have. So now what we have plus minus future value. As I said to you that if we do have future value, please make sure that you write the amount of the future value as plus or minus. So plus minus future value 2.5, then you say this is FV. Then we set our interest, it is 8.55, and we divide by 4. Remember, This 8.55, I want to highlight the fact that 8.55 is the interest for the full year. Take note, this is the interest we earn for the full year. But now we need to know how much is the interest for 3 months. If our interest for the full year is 8.55, or how much is the interest per quarter. So now hence we divide by 4 because there are 4 quarters in a year. So now we need to say our interest for the full year, we divide it by the number of quarters in a year, or by the number of compounds in a year, which are quarterly and 4 times in a year, so that we get to know how much is our interest per quarter, so that we earn that interest per quarter and we compound it and add it back to our original amount or principal amount. So let me say 8.55 now divide by 4. So now we know that every quarter will be earning interest of 2.1375. This is the interest that will be earning every quarter, because 8.55 is the interest for the whole year, but we need to know the interest only for a quarter, and we add that to our capital. So this will be our I, interest, I divide by y in our calculator. Then now we come to our n. Our n, it is 5 years and 3 quarters. Remember, a quarter is made of 3 months, don't forget. 5 and 3 quarters. Now a quarter is made of 3 months. So now if there are 3 quarters, meaning it is 3 months, 3 months, 3 months, meaning 3 months plus 3 months plus 3 months. These are 3 quarters because a quarter is made of 3 months. That means 3 quarters is 9 months in simple terms. 3 quarters is 9 months. So in other words, 9 over 12 will give us a decimal of 0.75. You can just verify that 9 over 12 gives us 0.75. Same applies as 3 over 4 will give us the same 0.75. Let us verify that 3 over 4, it is 0.75. So 9 months out of 12 months is 0.75, which is 75% of a year, if I may say so. And also 3 quarters is again 75% of a year, 0.75. So this means the same thing in simple terms. So now we can say 0.75 is in years and 0.75 is in years. So now we need to convert that quarter into 0.75 years, so that now we can convert this years as 5.75. In other words, then we multiply this by the number of compounds in a year. Remember, our interest is compounded quarterly. How many quarters do we have in a year? There are 4 quarters in a year. And I want to show these calculations in details. We said 0.75 plus 5, it gave us 5.75. Times this by 4, how much do we get? We get 23 times. 23 times, this is not years, it's 23 times. That means the interest will be compounded 23 times over the period of 5 years and 9 months, because we have invested this amount which we don't know, but the amount was invested for 5 years and 9 months. So now that means how many, then we ask the question of how many times will the interest be compounded over the period of 5 years and 9 months. The interest will be compounded over a period of 23 times, meaning it will be compounded 23 times. So that becomes our n, being the total number of compounds for the entire period of the investment, which is the investment that we are looking for. Now I also want to highlight this because in the later calculation we will deal with this. Now if we say the number of compounds over the investment period are 23 times, now we need to be able to convert this back into the number of years. Take note of that. We need to say if this interest will be compounded 23 times, that means now how can we convert this 23 times back to the number of years? If we're given n as 23 times, which is the number of compounds, then we're required to calculate back the number of years to say how many years was the amount invested for if it was compounded quarterly. So now what do we do in this case? We need to divide by the number of compounds in a year, because in this case we multiplied by 4 in order for us to get to 23. So we need to divide by 4 in order for us to get back to the number of years. Take note, we multiplied by 4 in order to get to 23, then we need to divide by 4 in order for us to get before the multiplication took place. So now that means we need to say divide by the number of compounds in a year, which is 4 compounds in a year. Therefore now we'll say 23 divided by 4. 23 divided by 4 will give us 5.75 years. And please take note of the fact that we divided by the number of compounds in a year, because there's a question later on that will require us to calculate n, and when we calculate our n, it will give us this 23. Then now we need to work backwards and calculate the number of years that the investment was invested for. And I want to leave this as it is because I will need it later on in my calculations. So now we are looking for what? We are looking for the present value. Present value is the amount that was invested, which is the one that we're looking for. So now in our calculator, we say comp PV, then we see how much was our present value. Remember, there's a video specifically on how to punch your calculator. It shows you everything and every detail. But please be reminded to clear your calculator all the times, where you say second function alpha 0, 0. Then after now we say plus minus 2500 FV. Then I will say 8.55 interest. Then you say 23N. Remember, if you want, you can say 5.75 times by 4. Then you say N, or you can just say 23N. Remember, we're not dividing by 4. This 4 was divided in order for us to get back to the original amount. Hope you still remember that. This is what we did, converting back to the number of years. Now, we said 23 is n, or 5.75 times by 4. You press n after. Then after we say compute present value. Then our present value amount, you just recalculate that again. Plus minus 2500 is our future value. Then we say 8.55 divided by 4. Don't forget that is our I. Then you say 5.75 times by 4 is our n, and you compute our present value. Now our present value becomes an amount of 1,537 rand 2 cents. Now this is the amount that we have as our present value. So now we say this is the amount that was initially invested, the amount that was initially invested. And we invested this amount for a period of 5 years and 9 months. Remember, 0.75 is the 9 months that I showed you. In order for this amount to become 2,500 at the end of 5 years, 9 months, which was compounded quarterly at 5.5%, 8.55% of interest. And now that is the first one. We go to number B. We go to number B, and we see that number B, we don't have the future value. That means obviously we are looking for the future value, because sum accumulated, which is S, is the future value that we're looking for. So now if we're looking for the future value, then our present value, we must write it as negative, plus minus 1,250. Our interest is 6.67%, and our n is 3:2/3 years. And I want to highlight that is also in years. That is still not a problem writing years, and I don't know how I forgot to write years there. Now we need to convert this and be clear in terms of that the 3 is to 2/3 years. We need to say 2/3. Then we say 2/3 3 and see how much do we get. 2 over 3, how much we get? 0.66. Remember, this is less than a year. So now what do we need to do in this case? We need to say multiply by 12 months in a year so that we know how many months is 0.66 or how many months is 66 or 67% of a year. So now we discover that it is exactly 8 months. Again, 2 over, it was 2 over 3, 2 over 3. That's what we get. Then we multiply this answer by 12 in order for us to see that this is 8 months in a year. So now that means this is 3 years plus 8 months. 3 years plus 8 months. So now if this is 3 years plus 8 months, then it is very clear that it will be 3 years. We know that 3 years is 36 months. 3 years is 36 months. So now it will be 36 plus 8 months, meaning 36 months plus 8 months. Remember, 36 months, it is 3 years times by 12. 3 times by 12 is 36, plus the 8 month being 2 over 3. We get a total of the month being 44. So now that means this investment was invested for a period of 44 months. This investment was invested for a period of 44 months. For a period of 44 months. So now that is 44 months, which is 3 is 2 over 3 years. Now it is very important to be good at converting the fractions into the number of months. Very important, and into the number of years. Therefore now, what is our main focus is also on the fact that our M, which is frequency, is monthly. That means our interest is compounded monthly. That means it's compounded 12 times in a year. It's compounded 12 times in a year. And our I must be divided by the number of compounds in a year. There are 12 compounds in a year if the interest is compounded monthly, because there are 12 months in a year. So now we need to be focusing on that. And 44, we say, how many compounds do we have? It is 12 compounds. So now this is already 44 months. We need to ask ourselves if how many months do we have in a month. And I want to say this once again. How many months do we have in a month? Because our interest is compounded every month, meaning once a month. So now how many months do we have in a month? There's only 1 month. So our N will divide by divide by 1. So this is very, very important to take note. Remember, in the previous one, we could have said, just to remind you, 5 times by 12. The previous one, which I did not mention, we have 69. If you recalculate that, 5 years times by 12, it will give us 60 months, so not 69. It will give us 60 months plus 9 months. I just have the 69 already in my mind. 60 months plus 9, it will give us 69 months. So now if we wanted in the previous one, sorry, I just remember this one now. If we wanted in the previous one, we could have said 69 months. Then we could have divided 69 months by the number of months in a compounding period. Meaning by number of months in a quarter, because the compounding period here was a quarter. So now I could have said, how many months do we have in a quarter? Then I could have said there are 3 months in a quarter. Then I could have said 69 divided by 3. Then if you say 69 divided by 3, how much do we get? We get to the same 23. The same 23 that I've calculated as 23 in terms of 5.75 times by 4, that gave us 23. Please guys, this is very important, and I don't know how I almost forgot from the previous question. Now that is also in alignment with what we have done here. Here we say this investment was invested for 44 months. Then I will say for 44 months, it will be 44 divided by the number of months in a compounding period. Our compounding period is monthly. How many months do we have in a month? There's only 1 month. That is why we divide by 1. In this one, it was quarterly. Then we said, how many months do we have in a quarter? There are 3 months in a quarter. Then we divided by 3, and that gave us the same 23 as you have seen in my calculations. So I'm highlighting this because it is very important to note. So now we do have our present value, which will be plus minus, and we are looking for the future value. This is what we are looking for. Then now let us do the workings. We have plus minus 1,250 as our present value. Yes, 1,250. Our present value, 1,250 is our present value. Our interest, it is 6.75 divided by 12. How many times is the interest compounded in a year? Then now we have our n. Remember again, our n, we can say 3.66666 times by 12. The choice is up to us. Remember that 3.6666, which is a different thing that I'm bringing now, it is the 2 over 3 equals plus, now we don't forget, plus how much? Plus 3. That means 3.6666 times this by 12, which is the number of compounds in a year. The interest is compounded monthly, meaning 12 times a year. We can see that this still gives us 44, or as we could have said, 2 over 3 gives us 0.66 times by 12. We want to know how many months is 0.66, because 0.66 is less than a year. So now it will be 8 months plus the full year, the full 3 years, which is 3 years is made of 36 months. 36 plus 8 will give us 44. So now either way, you still get to the same 44 that we have. So remember, if you decided to take 44 as 44 months, you'll have to say 44 months divided by 1, which still gives you the same 44. Then after, what are we calculating, or what are we computing that is missing? We are looking for the future value. How much is the future value? Don't forget to say a second function alpha 00 to clear the calculator. Plus minus 1,250 is the present value. 6.75 divided by 12 is our interest. Then after, we have 44, which is our n. Then what are we looking for? We say comp FV. We are looking for the future value. Future value, it is 1,599 rand 91 cents. So now this will be the amount that will be in the account at the end of 44 months. If 1,250 is invested once off and stays in the account, earning interest of 6.75% per annum compounded monthly for a period of 44 months. So this will be what will be in the account, and the return does not look so good, to be honest. 1,250 to 1,599 is not a good return, to be honest. However, that is not the main focus. The main focus is understanding the basic calculation of the present value, future value, interest rate, compounding period, and our n and m being the frequency. Then now we go to number C. Then we look at number C. Number C, we are told under number C, or we are given under number C, that future value is there. And please remember, if there is a future value, that need to be plus minus. If we have both of them present value, only one must be plus minus. And if both of them are there, please make sure that it's only the future value that has the sign of plus or minus, which in this case it is the 4,675. Present value 3,965. There is our present value. There was our future value. Interest is what we are looking for. We have our n in the number of months now, 33. Remember that 33, we can say 33 divided by 12, so that we get to see how many years. This will be 2.5 75 years. And we know that this is 2 years plus 9 months already now. We know that 0.75, it is 0.75 if you want 0.75, just to verify that times by 12 is equal to 9 months. 0.75 multiplied by 12, we see that it is 9 months. So guys, I want you to master all this very much in terms of the rounding off and the conversion of month into years. So we have 2.75 years, which is 33 months. Our interest is compounded quarterly. How many months do we have in a quarter? We have 3 months in a quarter. So now if we want to move from the number of months into the number of years, then we can say now 33 months divided by 3. This will give us, this will, if we want to know how many 3's go to 33, it will be 33 divided by 3 months in a quarter. 33 divided by 3 months in a quarter, this gives us 11. So now that means the interest will be compounded 11 times, because every third month we compound, every third month we compound, and every third month we compound. Now that means the interest will be compounded 11 times. At the same time, you could have said 2.75 times by 4. Take note of that. 2.75 times by 4. If you have the number, or you have the figure as the number of years, or the figure in years, you multiply by the number of compounds in a year. If you have the number of years as in years, you multiply the number of compounds in a year, of which if the interest is compounded quarterly, that means we are compounding it 4 times a year. So now you multiply that by 4, which is 2.75 multiplied by 4, we get how much? 11. But if we have the number of months in this case, which is 33 months, if you have the number of months in which the amount was invested, and now you know how often it was compounded quarterly, then now because these are months, we need to say how many months do we have in a quarter. We say the months that we have in a quarter, we have 3 months in a quarter. So now if we invested this over a period of 33 months, we need to say divide by the number of months in a quarter, so that we know how many quarters are in the number of months that we have. Meaning how many quarters do we have in total of 33 months, so that we can know how many times will this interest be compounded. So now 33 divided by 3, which is the number of month in a compounding period, or in a quarter in this case, then this will give us 11 times, meaning the interest will be compounded 11 times over the period of 33 months, because every third month we are compounding the interest. Every third month we are compounding the interest. So that means 11 times the interest will be compounded over the period of 33 months. I hope I've made myself, guys, very clear when it comes to this. And this dynamic is very important in compound interest, and is very important. You'll be dealing with it, I think, also when you deal with the topic of annuities. So now what are we looking for? We are looking for the interest. Please don't forget that. So now let us go there and know that the interest is divided by the number of compounds in a compounding period, or in a year. Now if there was interest here, you could have divided by, remember, we could have divided by 4, because our interest is compounded quarterly. So now that means when we do our normal calculations of any other unknown, we could have divided by 4 here. But now what are we looking for? We are looking for the interest in this case. So now we need to make sure that we apply this 4 in terms of multiplying by this 4 in order for us to get to the interest for the full year, because the answer that we are going to get will be the answer after the interest was divided by 4. So we need to know the interest for the full year before it was divided by 4, which is the number of compounds in a year. Now let us go further with our calculations. We have plus minus our future value, and our plus minus future value 4,675. It is 4,675 is the future value. Then we should have an amount of the present value, which is 3,965. 3,965, 3,965, it is our present value. Then we have our n, and we know that our n is 11. It is 33 months. Then you say, now if it's 33 months, how many months do we have in a compounding period? And our compounding period, or our compound period our compound, in fact, is every 3 months, meaning every quarter. Then how many months do we have in a quarter? We said 3 months are in a quarter. And remember, this is in months. If this is in month, you divide by the number of months in that compounding period. But if your amount or your number is in years, 2.75 years, then you need to say how many times do we compound interest in a year, because this is in years. So now we need to multiply by the number of compounds in a year, which is 4 times in a year, because there are 4 quarters in a year. So please guys, don't confuse this. It is very important for you to master. At the end of the day, you will still get to the same 11 that we have. I just want to stick with that 33 divided by 3, because others they have given us, we did apply that method in the first scenario of 5.75, and I continued with that again when it comes to number B. So now number C, I want to stick with exactly how it should be. So now we say compute. What are we computing? We are computing interest. Compute I divided by Y. Then we need to multiply the figure by 4 in order for us to get to the interest for the full year before it is compound divided by 4. Then now don't forget second function alpha 0, 0. Then we say plus minus 4,675 is our future value. 3,965 is our present value. 33 divided by 3 is our n. Then we say comp interest, meaning compute IY. It is 1.508753094. This is the interest after we have divided by 4, meaning is the interest after we said 8 divided by 4. Whatever interest that we get here, this is the interest that we see there at the bottom. Let me just give you this example. So now when you say 8.55 in this scenario, 8.55, when you set under that number A, 8.55 divided by 4, we got how much? We got 2.1375. In order for us to go back to the interest for the full year, what do we need? We need to say times by 4. So now if you say times by 4, you get to the interest for the full year. So this is exactly what is happening. Whenever you're calculating interest, you get your interest after it was divided by the number of compounds in a year. And in this case, we know that the number of compounds in a year are 4 times. Why am I saying 4 times? Because our interest is compounded quarterly. That means quarterly, that means interest is compounded 4 times in a year. So now just to go back there to clarify you, quarterly meaning 4 times in a year. Quarterly means 4 times in a year. So the interest that we have is after we have divided by 4. So we need to say times by 4 in order for us to get to the interest for the full year. Then our interest, it is 0.035012374% per annum, compounded quarterly. Please write the full quarterly. just for the sake of space. Then we go to the last one, number D, that you've been longing for. Number D says that we do have future value, we do have present value, we do have interest. We need to know our N. And now is compounded, the interest is compounded 2 monthly. 2 monthly meaning 6 times a year. 2 monthly meaning 6 times a year, because if you know maths, it will tell you that there are 6 2 months in a year, or 2 goes 6 times in a year of 12 months. So now this is where our question mark is. 3,850 is plus minus future value. This is our present value. Please don't forget, this is our present value. 3,300. Remember, future value 3,850 must be our plus minus 3,850 is the future value. Then we have our present value, and our present value, it is 3,300. This is our PV, and our interest, it is supposed to be there, and our interest is 10.25 divided by the number of compounds in a year, which is 6 times a year. So now we say if it's 6 times per year, then we need to say 10.25 divided by 6. Then what are we looking for? We compute our N. Previously, did we say compute I? Okay, yes, compute IY, then times that by 4. Compute IY, then times that by 4. So we compute our N. Now when it comes to our N, once again, our N, we will need to divide with it. Divide by 6 in this case, because it is compounded 6 times a year. So now let us go there. Then we don't forget to clear our calculator. Second function alpha 00. Then we say plus minus 3,850. It is the future value. 3,300. It is our present value. 10.25. 10.25 divided by 6 will be, or divide by 6 will be our interest. And what are we looking for? Compute N. Now we get our N as 9.100312,173. Then now we need to divide this by 6 in order for us to get to the number of years. We divide this by 6. Remember, once again, in the previous questions, just to go to number A. In number A, we mentioned we multiplied by 4. After we multiplied by 4, we got to 23. And I said, how then do you move from 23 back to the number of years? And I said to you, what you need to say 23, which is the number of times the interest. Remember, 23 is the number of times the interest will be compounded over the period of the investment. So now this 23 is the number of times the interest will be compounded over the period of the investment. Similarly, this number, which is 9 point something, it is the number of times the interest will be compounded over the period of the investment, the number of times, which is exactly the same as this 23. So now we need to know for how long was this investment invested. That means now what are we looking for? We are looking for the number of years now. So if we know that in order for us to get to 23, we said in order for us to get to 23, we said something which we don't know, question mark, multiply by 4 is equal to 5.75. That means when we are looking for this 5.75, then we need to now divide in order for us to get to the number. I think I've done it wrong. We know that in order for us to get to this 5.75, we multiplied something by 4, or we multiplied 23 by 4, not something. We multiplied 23 by 4, or sorry, so not 23 by 4. We said 5.75 times by 4, it gave us 23. Yes, I'm just doing things wrongly now, sorry for that. In order for us to get to 23, we said 5.75 times by 4, it gave us 23. So now we need to move back from 23, going back into 5.75. Exactly, that is what I want to say to you. So we want to move back to 5.75. We want to move from 23 to 5.75. So now, because we multiplied to get here, then we need to divide by 4 in order for us to get to the number of years. So guys, I hope I'm clear with that very much. That is exactly what I'm meaning, that we have this 9.100, which is the number of times the interest will be compounded, which we know that we multiplied by the number of times the interest was compounded in order for us to get here. That is why now we need to divide by the number of times the interest was compounded, of which in this case it is 6 times, compounded every 2 months. So now what does that mean? That means we will then get to the number of years. Number of years will be divided by 6, which is 1 year and 5.16718 So now this is in years and not in months. And remember, this is times. Then if we, let us say you were required, how many times was the interest compounded? Because we know that the interest was 10.25. Then the question is, how many times was the interest compounded over the investment period? The interest was invested 9.10 something times. This is the times in which the interest was compounded. Therefore, now that time divided by 6, which is the number of compound in a year, will give us the years, meaning this interest this amount must have been invested over the period of 1.56 years. So now this is the final answer. With that, guys, you've been wonderful audience, and I will say this with love and with the love and the love and the love for you. Please go through this question 2.3 before you watch the next video of this activity. Otherwise, I'll do it again so that I make sure that you master everything in compound interest and you don't get anything less than 100% in this question, and also in other questions. Attempt this question and you will see that everything that I've explained above, you will apply it here and you'll get excited when you look at the solution and you see that you got everything 100% because of the help of this current video. With that, guys, thank you very much. You've been lovely audience. Stay well, stay safe. God be with you. Thank you.